So let's look at the number of bends on a graph. So we're going to connect, we're going to connect the equation that we have of this polynomial to what that looks like on the graph, or what it could possibly look like. So number of bends. A bend is where a graph changes from increasing to decreasing or decreasing to increasing, where the graph changes direction. Using your graphing calculator, and actually, sorry, for number of bends, I don't want to say just that. I'm going to count this as a bend as well. And the function doesn't really change from increasing to decreasing, but it has two bends on it. There's a bend number 1 is right here. Whoops, let's make that a little smaller. Bend number 1 is right here, and bend number 2 is back this way. And it doesn't really switch from increasing to decreasing. So while this is a pretty good definition, it's not exactly accurate. I'm going to say that bends, we just are going to kind of look at them and see that the graph turns. So we're going to graph these you should graph these on your graphing calculator. It's good practice. So you go to the y equals button, top left, and you type in 3x plus 2, and then you hit graph, and you should be looking at a graph. I'm going to graph them on decimals. So, whoops. 3x plus 2 looks like this. It's a line. Has a y-intercept of 2. So what degree is this? Remember, as review, the degree here is 1. When there's no exponent on the x, it's really a 1. We're just not showing it. If there's no x at all, you could think of it as degree 0. So the highest one wins. So this is a degree 1. And just for review, the name of that function with a degree 1 is called a linear function. And how many bends does it have? It has 0 bends. So degree 1 has 0 bends. Let's look at this one. The degree of this guy, remember, if there's no degree there, it's a 1, no exponent, and that one's like a 0. Highest one wins. This is already put in standard form. They put the highest one first. So this is a degree 2, and for review, that's called a quadratic. How many bends does it have? X squared minus 2x minus 6. Let's see, I have that one here. You can practice graphing these on your calculator. So you can pause it, go to y equals, type in the stuff, and see if you get this graph. So it's got a y-intercept of like -6, and the vertex has been shifted right and down some. So we just want a quick little sketch here when we're just looking at number of bends. So maybe it looks like that. Let me do that a little better. Something like that. And how many bends does it have? It's got 1 bend. It just kind of turns once right through here. That's 1 turn. Now let's look at a cubic. So again, you're going to pause it here, and you're going to want to graph this on your calculator and see if you can do that. It's good practice. The highest power of x is 3, so its degree is 3. And again, for review, that's called a cubic. I graphed this one here, so after you've paused it, you can check and see if your graph looks something like that. This has 2 turns. I see a turn here, that's 1, and a second turn over here. Okay, let's look at a quartic. Highest power of x is 4, so the degree is 4. Remember, for review, it's called a quartic. So I graphed that one in decimals. You should pause the video and graph it on the calculator. Alright, so welcome back. This one looks like this. How many bends does it have? It has 1, 2, 3. Excuse me, so it's got 3 bends. We notice a pattern that's going on here. A degree 1 has 0 bends, a degree 2 has 1 bend, a degree 3 has 2 bends, And I want to stress that these are typical ones. They don't always have to have that many bends, but that's the most they can have. They can't have more than 3. Like a degree 4 can't have more than 3 bends. It doesn't have to have 3 bends. There's a degree 4 that looks like this that has 1 bend. All right, so a degree 5, which is called a quintic, should have 4 bends at most. So if we graph that, you should do it on your calculator. I see 1, 2, 3. Yeah, I see 4 turns, 4 bends. All right, so we're going to make a rule here. Given the degree of the polynomial, which, as a review, the maximum number of bends, as a review, polynomial is the highest power of x. The maximum number of bends, it's where the graph turns. I don't want to say changes directions. I'll say turns. In the graph will be n minus 1. So actually I'll write it like this. The degree minus 1. Now again, the key here is maximum. It doesn't have to have that many turns, but it has at most that many turns. So degree 4 has at most 3 turns. A degree 1 would have no turns. A degree 2 has at most 1 turn, and so on and so forth.